I'm Learman, and my presentation was over 3D bioprinting and artificial organs, which is how scientists are creating organs using 3D printing technology and why it matters in modern medicine. I chose this topic for numerous reasons. It first piqued my interest when I was watching Grey's Anatomy, which is a show by Shonda Rhimes, and they've mentioned it more than once, and I thought, oh, that sounds really cool. And I've always been interested in the medical field, and I'm actually going into the medical field as pre-PA. And then organ shortages is a major issue in healthcare. Sorry, I'm next to middle schoolers. And it stands out to me a lot because of the shortage and how it's one of the biggest issues. And then it also sounds really cool to me because it's so futuristic and unrealistic, but it's not. And then some background is that vital organs and organ systems keep us alive, like the heart, the liver, the lungs, and all this in the system it goes along with. And then organs failing, and what it means is when an organ is not working to its full potential, which is often fatal. And there's multiple stages of this, which the last two stages are end stages, and that's when they're near failure. And because of this, organ transplants are life-saving for people who get them. And there's a big organ shortage problem because 103,223 men, women, and children on the transplant list die or are on the transplant list. And then 13 people die every day waiting on organs. Every 8 minutes, another person is added to the transplant list, and every donor can save 8 lives and enhance 75 more. But why aren't there more donors? Because it's a very big issue. It's because there's a limited supply, because people have to die or they have to willingly donate an organ for someone to get them. And even then, a lot of organ donors, they might not be able to give up their organs because they have to be eligible for it. They have to match people, so their chance of rejection of the organ in the new body is unlikely. And then 3D printed organs are basically the same thing as a regular 3D print, but instead of plastic, it uses living cells, which is the goal is to be able to use those living cells that are printed as working human tissue and organs. And then the idea is that these would work better than a transplant because it'd be made out of a person's own cells, so the chance of rejection is severely decreased. And then materials used are stem cells in bioink. And stem cells are unspecialized cells that can develop in different cell types. So scientists will collect and grow these cells and then combine it with bioink, and then that is what will be printed out because the stem cells can become specialized with the printing and mixture. And then 3D bioprinting works with multiple steps. The first one being doctors taking scans, like an MRI or CT, to see the design of the organ. And then these scans create very detailed pictures of the patient's organs and tissues, and they show the shape and size and damage, and it ensures that the new organ will match the body. And then a digital 3D model is created so that way they can get a better idea of what they're working with. And then the printer deposits layers of the bioink precisely, just how a regular 3D printer would. And that makes it super exact and super precise, what you need because it's going into someone's body to replace an actual organ. And then the printed tissue is placed in a bioreactor to grow and strengthen because, yeah, it's printed, but it's not necessarily strong enough to go in a body. So it'll be similar to, an actual organ is formed, and it'll become more stable and functional, closer to a real organ. Current achievements are that it's slowly being used in real life to print skin and cartilage and simple blood vessels. And then they started with these because they're easier to make because the cells aren't as complex, because full organs have complex shapes, chambers, and filtering systems, and it's not just a few specialized cells, it's a bunch of specialized cells working together. Recent advancements are a breakthrough with printing realistic blood vessel networks, and this is critical because it can help deliver oxygen and nutrients, because beforehand the stem walls were too thick, so the cells inside of it were dying, so they had to fix that so they would live. And now it's a lot better because the stem cells are being able to withstand more and are more functional, which is an important step towards building larger organs. And then most recent experiments are with mice because their organ systems are predictable and similar to humans. And then scientists are studying the function, survival, and safety of them. Like, if the cells stay alive over time, if they grow, connect, and form stable tissue, and if the printed tissue does what it's actually supposed to, or if the body rejects the tissue, and if it harms harmful reactions like inflammation or abnormal growth. And it's also difficult to use these on humans because it's still being researched, and the FDA and a bunch of other organizations are very strict, and they're very iffy on it because, yeah, it's been tested a lot and it's in the works, but they haven't tested it for like long term. It's still all very recent. And this can benefit society in multiple ways because it reduces the organ shortage by creating an unlimited supply, reduces transplant rejection by using the patient's own cells because patients are less likely to reject their own cells, and shortens the waiting time for patients and could lower long-term healthcare costs because patients wouldn't be in the hospital for as long, and it opens new doors for medical treatments. Future possibilities are fully functional organs like hearts, kidneys, and livers, which is the biggest ones that we need. And then hospitals being able to have those printers on site, so it'd be very convenient for them. And then the potential to extend human life expectancy, especially with personalized medicine becoming more common with everyone being different. Challenging controversies are the fact that the new organs, the bigger organs, are so complex that they can't really figure it out yet, and keeping those complex organ systems alive. And then ethical concerns are cost and access, like who gets them, with wealthier countries being able to afford it more or wealthier people being able to afford it more. And then, like I said prior, the FDA is a regulatory barrier because they're very strict about how they go about things. So in conclusion, the problem is that not enough organ donors for all patients, leading to more people not to survive, and the solution is the 3D bioprinting, which creates organs using a patient's own cells, which could provide many custom-made organs and unlimited ones, and reduces rejection wait times. Progress so far is that skin, cartilage, and simple blood vessels can be printed, and they've been tested successfully in labs and animals, and technology is improving and getting closer to full organ printing.